Hi, my name is Luis. I am a teacher at the Engaging Math Circles, and today I want to help you how to find pi in your home. And the reason behind this is because we are familiar with this irrational number, 3, 1, 4, 1, 5, and more digits. We use it for circles in geometry, circumferences, areas. We even have a pi day, right? But it's important for us to know where it comes from and just not using it because it's there in the textbooks. So what you're going to need is something round. I am using my coffee mug, a ruler. If you have measure tape, even better. If not, you can use a lace. I found this at my house. Some paper, graphing paper, if it's possible. You can download a PDF file and print it if you don't have one at your place. Scissors, color pens, and of course some patience. The first step is to use your round object to make a circle and try to make this in the center part of your paper. Right? I just draw a couple of lines in here to have a guide, and then I put the mug on top, just like that. And then I use a pen that wasn't that thick because I want to be really precise with the measure as much as possible. The step number 2, of course, is measuring it. I found the diameter of this object was 8.5 centimeters. If you're wondering what is the diameter, is a line that connects 2 points, the circumference, and passes through the center of the circle. The step number 3 is with the measuring tape or a cord, you have to measure the circumference, which is the line that surrounds this circular figure. And I try to use something firm that doesn't stretch when you pull it. So I'm trying to be precise with my measurements. And what I found was this circumference, which I am going to call C, was, actually I have that on my ruler, 26.8 centimeters. So the ratio or the relationship that we found between these two numbers, of course, is the division of them, 8.5. What happens to the units? Well, if you divide centimeters by centimeters, the units are going to disappear, so you're just going to obtain a number, which is the definition of a ratio in the first place. So I don't know if you see it, but it's 3.15. I'm going to round it to 2 decimals, 3.15, which is really, really close to this number, right? So I can conclude that my percentage of accuracy is 0.36%. Less than 1% is really, really, really close to the real number. We have these formulas. Now you know where it comes from, which is, to me at least, the most important thing ever. And I am going to highlight this part because we are going to use it, or I want you to use it, to find the area of the circle. Some of you might know what the formula is, but this is the explanation. You can use the same circumference that you draw. Try to paint some of them so you can keep track of what elements you are going to cut because you're going to cut them. So I wanted to paint this in here, one red, one white, or you can choose whatever color you want it. Then I folded this to cut it faster, and then of course I obtained the circle itself. And here we have a picture of the circle outside of the, well, that was a terrible circle. This circle outside of the paper, and so you're going to try to cut the best you can through these lines. Like, pretend that this is a pizza, so you're trying to make every little piece of this just like the other, okay? And then don't lose anything. You're going to put them in this form. If you see here, this is a piece of the circumference, right? Imagine that this is this one over here. I'm going to use a different color to mark this arc that is on top, right? And then another color for a white piece, maybe this one. And I am going to put it in here, in the other direction. So again, the arc or the portion of the circumference are going to be on the edges of this figure that I am going to form. And I should have something like this, okay? And you see that there is a missing piece that if I put that in here, this shape looks weird. It doesn't look like something that I can recognize easily. So what I want you to do is to cut this in half and put one of those portions over here and the other one over there. And now this looks kind of a rectangle. I recognize these heights as the radius, because remember that this piece was cut in half. That could be the line that created this segment over here, and of course it's going to be the one over here, right? And this is the radius. So far we know that the height of this rectangle is equivalent to the radius. Let's just call it r. I'm going to use a different color over here, and we are observing that these arcs that come from the red pieces that we cut are here, part of the circumference. If I put all these lines together, what I'm going to obtain is half a circumference. So I can say that if the circumference, remember that we had the formula circumference equals 2 times pi times r. Well, the green part only corresponds to pi times r. And what is the area of a rectangle? The area of a rectangle is the base times its height, right? If the base is pi times r, and the height is also the radius, this is going to be pi times r squared. And that is how the magical formula appears. And now you know how to find it. You can actually do it at your house. If you cut more pieces, of course, this is going to become more and more and more close to a real rectangle. And the best thing is that if you understand how to find a formula by yourself, it doesn't become a formula that you have to memorize. Now it's something that makes sense to you, and you can also teach these little tricks to someone you know. I hope that you enjoy this, and I'll see you soon. Have a great day.